This is video number 4 in the series of calculating concrete slabs. At the end of this video, you will be able to specify concrete regarding the functional restraints, regarding the functional conditions. This video is the same as video 20 to 25 of the playlist Concrete Beams 2022. The functional conditions of concrete follow a certain path of reasoning, and you start always with the environmental class. This is valid for the Belgium application document. From the environmental class, you can have the exposure classes. After that, you can specify the concrete type, which includes the concrete quality, and then you can start calculate the concrete cover and the maximum allowed crack width. The environmental conditions, the exposure classes, are E0, which is non-aggressive environment. Most of the time this is for non-reinforced concrete or plain concrete. EI is inside buildings, it's inside offices and family houses. The exposure classes, corresponding exposure classes are X0 and XC1. And then you have another group, which is EE, and this is for outside buildings. For the outside buildings, you have 4 different groups. The first one is no freeze attack. This is, for instance, for foundations below frost level. Then you have a second group, which is freeze attack, but no contact with rain. So this, for instance, a roof-covered parking lots or open galleries with roof or storage cellar. Then the third group is freeze and contact with rain. This is a wall, for instance, exposed to rain. And freeze and de-icing agents, part of road infrastructures. The EE4 is the 4th group. Then you have the environmental group with contact with sea environment. You have 2 different partitions in it. It's contact with seawater. It's no contact with seawater, but with air carrying salt. And there is another group when in contact with seawater. When in contact with air carrying salt, it's defined by a region up to 3 kilometers from the coast, or when you are in the vicinity of brackish water. Then you have 2 groups, ES1 and ES2, which is no freeze or freeze. And then in contact with seawater, you also have 2 groups. This is for concrete submerged in seawater and concrete in a splash zone. You will see that the most severe condition is concrete exposed to the splash zone of seawater, like K-walls, for instance. And the third group of environmental group is the aggressive environment. There is a list of chemicals, and depending on this list of chemicals, you will be in a class EA1, 2, or 3. In practice, this will influence the composition of the concrete, but you will always you have to apply to the environmental conditions from the EE group. Now, to make life easier, you can use a very simple memory aid. For the EE classes 1 to 4, you just have a table frost, rain, and de-icing. And then you will see for EE4, the 3 is valid. For EE3, it's only frost and rain. EE2, it's only frost, and E1, it's none of the 3. So this is a very easy tool to remember what is EE1 to EE4. The second group is the ES group. And you also have the 4 levels in this group. Then when you are not in contact with seawater, but not in contact with seawater, but only with and not in contact with frost, then you have ES1. When you have no contact with seawater, but contact with frost, then you have ES2. And then for ES3 and 4, you have contact with seawater for the 2, but when it's submerged, it's ES3, and when it's in the splash zone, ES4. The concrete cover is the distance between the surface of the reinforcement and the concrete surface. That's the exact definition of concrete cover. The nominal cover shall be specified on the drawings. This is the nominal cover, and this is C, the cover, the concrete cover of this black rebar. You see that the cover exists of a minimum value, which is for environmental impact. There is a tolerance on it, and the sum of those two is C nominal. You can now make some calculations for buildings with no special quality control. There is no prefab or slab geometry. If you got that, but there is slab geometry, sorry, and with fixed formwork, then if you make some calculations like that, then you will see that there is a pattern. And the concrete cover can be estimated as 15 millimeters plus the maximum diameter that you are used for reinforcement. This goes up for all environmental classes. When you have an environmental class EE1, then the minimum concrete cover must be bigger than 30. Also for EE2. For EE3, it must be bigger than 35, and for EE4, 30 bigger than 50. You have also limitations for the ES environmental class. This is easy to have a quick estimate of a concrete cover without calculating. Then you see that at least the cover must be 15 millimeters plus the diameter, the maximum diameter you used. You can put this in a table. You can combine it in one table. And for instance, you can see that for inside buildings, most commonly used for offices, for instance, then you have a concrete cover of 15 plus the maximum diameter. You can apply also the same trick for the ES environmental class. And then you will see if you have not in contact with seawater, but in contact with frost. So it's frost and sea air. Then you are in the ES2 environmental, and then the concrete cover is 15 plus diameter with a minimum of 40. Some definitions now regarding the reinforcement. For a slab, there is a reinforcement in 2 directions always. And you can then have 2 situations, or you are calculating the needed reinforcement when the needed reinforcement is situated in the second layer, or you calculate the reinforcement when it's situated in the first layer. The total depth of a slab is equal to the effective depth plus the point of gravity of the tension reinforcement. We denote with 1 the tension reinforcement and with 2 the compression reinforcement. Or you can say 2 is the least tension reinforcement and 1 is the most tension reinforcement. Then D1 is when you have only one, when you have the same size of the same diameter of reinforcement, which is mostly the case in slabs, and you have only one layer of reinforcement in the same direction, then the point of gravity is of course half of the diameter plus the diameter of the transfer reinforcement plus the nominal concrete cover. When you are dealing with the bottom layer, the real bottom layer of reinforcement is this direction, then of course the point of gravity is only half the diameter plus the nominal cover. You can calculate the needed concrete cover by the following method. First of all, you take the maximum value of surface coefficient and the nominal cover. The nominal cover is given by the minimum concrete cover plus a tolerance, and the surface number depends on the formwork. If you use fixed formwork, then it's 0. When you cast against prepared soil, then it's 40 millimeters. And when you cast against soil with a PVC sheet, then it is 75 millimeters. The tolerance is taken as 10 millimeters, but if you have an increased quality control, you can reduce it to 5 millimeters. The minimum concrete cover will be the maximum of C-min B, C-min dur, and 10 millimeters. C-min B depends on the maximum granulate size of the concrete. When it's bigger than 32 millimeters, then C-min B is the maximum size of rebars used, plus 5 millimeter. When the grain size is smaller than 32 millimeters, which is most of the time the case for buildings and offices, then C-min B is equal to the maximum rebar diameter. So you can already conclude that the minimum concrete cover is always bigger than the maximum size of bar that you are using for the reinforcement. And then you have C-min dur, and C-min dur is coming from a table from it's a table 44N. It's a table from Eurocode 2 part 11. There are several structural classes from S1 to S6, with S4 is a class for buildings and S6 is a class for instance, bridges. And for each environmental class or for each durability class, you will have the minimum required concrete cover. For instance, for a bridge, EE4, you will have for that's structural class S6, you will have C-min dur equal to 55 millimeters. You have the same table for pre-stressed concrete. Also, according to the structural class and the environmental class, you will have a certain minimum amount of concrete cover. The structural class, S1 is for temporary structures, which is for about 10 years. S2 is for replaceable structural parts, that's for 25 years. S3 is agriculture and similar structure, 30 years design life. S4 is for buildings and offices, it's 50 years. And then S5 and S6 is for monumental structures and civil engineering structures. In the past, there was S5, which was 95 years, and S6 for structures, for bridges. It's 100 years, but now it's in one group and it's for 100 years and it's called S5, but in fact it's S5 and S6 taken together. So I will use structural class S6 not to have the confusion with the previous S5 class. So the main or the most common structural class is S4 for buildings for a design life of 50 years and S6 for bridges with a design life of 100 years. So your concrete cover, the minimum required concrete cover, is related to your design life of the structures. You can the structural class, you can lower the structural class or increase the structural class depending on certain conditions. Suppose that you have used a strength class bigger than C3037 for an office building, EI, for this environment, for an environmental class, an internal environmental class, and you use concrete C3037, then you can reduce the class by 1. So instead of going to the structural class S4, you can use the minimum concrete cover for an S3 structure because you used concrete strength bigger than the required concrete strength. You can also have, when the member has a minimum slab geometry for slabs, then you will see that you can also reduce one class. Those two rules are cumulative. So if you use for a floor slab in a building, you use C3037, then you can reduce by 2 classes. Using special quality control of the concrete production with really severe actions if you do not comply with it, then you can reduce another class. So in fact, you can reduce 3 classes when you follow all those conditions. On the other side, when you want to design an office slab and you want to do it not for 50 years, but for 100 years, then you have to increase the class by 2. This is how you, or this is an example how you can specify the concrete. You start with the environment, then you put in the corresponding exposure classes. From a table, you can determine the type of concrete, from that the quality, and then you can calculate the needed concrete minimum cover, and you can specify the maximum crack width. So take now an example for a floor on the second level of a classroom in non-coastal area. We will specify, there is a special quality control on the concrete cover. The maximum rebar diameter that we are using is 20 millimeters, and the slab is cast on fixed formwork. We start with the main formula. For delta C surf, we have seen that we are casting against fixed formwork, so this component is 0. Next, we will have the C min. The C min B, depending on the maximum grain size, it will be smaller than 32 or bigger than 32, the maximum grain size. We do not know it now. It's not known at this moment, so it's not known. You put yourself on the same side and you can use the maximum diameter plus 5 millimeters. Of course, for office buildings, it's often less than 32 millimeters. So C min B is 25. For C min dur, we will have a look at the structural class, and the structural class is S4. But we can, because it's a slab, then we can lower the class by 1. So we arrive at S3. So it means that the C min dur is 10 millimeters. So the minimum concrete cover will then at the end be the maximum of 25, 10, and 10. So it will be 25. Delta C def, we have a special quality control in this example. So we lower it from 10 to 5, plus the 25 of C min, it gives you a nominal cover of 30 millimeters. Now we will have a look for the concrete type. We know that we are in EI, in the internal environment. For reinforced concrete, it will be this column. So you will have the concrete type at least T 0.65. The 0.65 is the water cement ratio, and the exposure class is XC1. For the T65, you will see the water cement ratio is 0.65, minimum cement content is 260, and the minimum strength is C1620. And then we can put this in our concrete specification. It's EY, the environmental class. Exposure class is X0, XC1. The type of concrete is T 0.65. Concrete quality is C1620. Cover is 30. And we know that for the environment EI, the crack width, maximum crack width is 0.4 millimeters. In all other cases, it's 0.3 millimeters.